This is an audio quality check. Checking audio quality. Audio quality check. 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 Thank you. Hello. Okay, we will be waiting 5 more minutes and then we shall start. So I'm actually waiting for more people to join here on the class. And again, this video will be available after the class. So if you are unable to attend today, you can always watch the video later on. And if you have any question regarding anything based on the topics we are going to cover today, or if you have any question regarding the topics we discussed earlier in earlier classes, you can always post them in the Google group, and I will definitely answer. Okay, you can email me directly as well. Yeah, I know there was one topic left in the previous class. We shall be dealing with that on the next class probably. Right. Right. So in this class today, we are actually going to learn how to do time domain operations on signals. And we shall be using a bit of Python programming for better visualization in this course, in this topic today. So I believe I gave you a link for a Jupyter notebook in Google Colab. So you can click that if you have the link for the Python programs associated with this with today's class, and you can actually follow along. Okay. For today, you can actually watch the stream only without any issue, and later on you can just head over to the link that I provided and execute the Python programs online using Google Colab, and check yourself. I mean, check for different types of operations online, right? Different types of signal operations, right? So actually, I developed quite a few Python libraries for studying and analyzing signals and systems. So those are actually available on my GitHub page. I will give you. So this is my GitHub page. Those who are familiar with GitHub, this is my GitHub page. In any case, we shall start shortly in 2 more minutes. So I would encourage you to not leave the stream. I'll be back shortly. Right. So I believe we should start today, right? So today in this class we shall be talking about time domain signal operations. So this is our topic of discussion today, right? Time domain signal operations. And right off the bat, time domain signal operations can actually be divided into two specific categories. So here is, and they can be divided into two specific categories. So the first category is amplitude operations on amplitude of a signal. And on amplitude operations, you have two specific types of amplitude operations, namely amplitude scaling and amplitude shifting. And you also similarly have time operations, and same thing here, we have time scaling as an operation and time shifting as an operation. So overall we actually have these four operations that we're going to discuss today. So we shall take any signal and understand how to do amplitude scaling, how to do amplitude shifting, and how to scale time. Okay, and how to do time scaling and how to do time shifting. So we are going to learn those regarding our signals that we discussed today. So with that said, let's proceed further. So all of you understand. So the first thing that we're going to see today is amplitude scaling, right? So it's pretty simple to understand, I think. So imagine we have a situation like this. Let me draw a very simple pulse, right? Easiest thing to understand, right? So, right. Say we have a signal, very simple aperiodic signal, and this signal has an amplitude of 1, max amplitude of 1, right? So this is xt, right? So pretty quickly, what would be 2xt? What would be that one? So if this is xt, what is 2xt then? So pretty simply, that would be xt, right, multiplied with 2. So this amplitude will only become double that, right? So if this is xt, then 2xt will simply have amplitude value right around here, and everything else will kind of be the same, right? So if this is xt, if this is xt, then this is 2xt, right? Pretty simple. So the amplitude just scaled by a value of 2. So amplitude got multiplied by a value of 2. I think this is quite easy to understand, right? Very simple to understand, right? So similarly, if I take a signal and multiply it with -1, what happens? The amplitude gets multiplied by -1. So when the amplitude of the signal is 1, it becomes -1. When the amplitude of the signal is, say for example, 2, it becomes -2, and so on and so forth, right? So with that said, let's quickly jump into the Python program I was talking about. So this is the Python program I just developed for you people, okay, so that you can actually better visualize what I want to say here. So here, if you look carefully, we have a signal. So I just very specifically constructed a signal to demonstrate different things about this time and amplitude scaling and shiftings. So all these time domain operations. So this is xt, right? So here I shall have the original signal, and here I shall have the shifted and scaled signals. Okay, so pretty quickly I have some slider bars here, okay, that you can simply move these slider bars, and accordingly the scaling will happen, okay, and you'll be able to see that on real time. So in any case, so this is a very simple example of a signal, right? So I believe all of you can see the signal, pretty understandable, right? Pretty understandable. And here, see, this signal has a value of 0 up until time t is equal to -1. Then at t is equal to -1, the signal jumps to a value of 1 and stays at value of 1 up until time t equal to 0. And then at t equal to 0, the signal again gets a jump and it jumps to 2, and it stays at a value of 2 until time t equal to 1. And then from at time t equal to 1, the signal goes down at a value of 1 to a value of 1, and then up to from time 1 to time 2, time 1 second to time 2 second, the signal gradually decays in a linear fashion to a value of 0. And then beyond time t equal to 2 seconds, the signal remains at a value of 0. So this is an example of a signal, right? So I don't think it's difficult to understand or difficult to follow, right? So now let's see. So if I multiply the amplitude of the signal by a value of 2, right? So say for example, if I multiply the value of the signal with an amplitude of 2, what happens? What happened just? So as you can see, this signal had, so I just moved the slider to a value of 2. What do you see here? The signal had a maximum amplitude of 2. Now this signal has a maximum amplitude of 4, right? This amplitude was 1, now this amplitude is 2, right? This gradually decayed from a value of 1 to a value of 0. This gradually now decayed from a value of 2 to a value of 0, right? So again, all the 0 values remained at 0, but other values simply got multiplied by 2 because amplitude has been scaled by 2. So if you look carefully, this is xt and this is 2 into xt. So I just multiplied the amplitude with a value of 2. So I think this is understandable, pretty easily understandable, right? If anybody did not get this, please tell me in the live chat. If you have any question, please post it on the live chat. I'll be happy to answer your questions. Right. So if this is all right, then do an amplitude scaling with a value of -1. What just happened? So I amplitude scale the signal with a value of -1. So this is xt and this is minus xt, right? So what did I just do? I multiplied all the amplitudes with -1. So wherever the signal had a value of 0, it remained 0. But wherever the signal had a value of 1, it has now become -1. Wherever the signal had a value of 2, it has now become -2. Wherever the signal decayed from a value of 1 to a value of 0, now it is basically going from a value of -1 to a value of 0. So you can understand what happened after multiplying with a minus sign, -1. What happened? The signal got flipped about the horizontal axis. So multiplying a signal with -1, so doing an amplitude scaling with a value of -1, it basically flips the signal about the horizontal axis, about the time axis basically, right? So this is the time axis, and about that the signal was flipped here. So this is basically a mirror image about this axis, right? Mirror image about this axis. So is there any issue with this? I think I can, if you can follow, please let me know. If you cannot follow somehow, please let me know again. Because many of our future discussions will be based on these. Hi, does anyone have any question? Right. All right. So similarly, if I just do an amplitude scaling with a value of -2, you can see what happened here. All the amplitudes basically got multiplied by -2, right? So it got flipped and got scaled, right? So the flipping happened because of this minus sign here. So if you have a minus sign here, the signal gets flipped about the horizontal axis here. And with this 2, what happened? All the amplitudes got multiplied by a value of 2. So whenever the signal had a value of +1 here, that became a -2. It had a +2 value here, it became -4, and so on and so forth. So all the value amplitudes basically scaled with a -2. So I think this idea is pretty clear, right? There is no issue with that. Right. So with that said, let's go back and make the signal what it was originally. So by default, so let's switch our discussion here. So I can simply say here, okay, if xt is a continuous time signal, again recall we are already only dealing with continuous time signals, then -xt is basically, or rather simply flips the signal about the horizontal axis, right? So again, And similarly, then multiplying the signal with any scalar quantity. So this is a scalar quantity. Which basically means any number, right? Simply multiplies the with a value of a, right? So if the amplitude was, say for example 5, now the amplitude will be 5a, and this happens for the entire signal, right? So now if I ask you this, so I have a question for you. So question for you, do tell me, if xt is a signal, how say if xt is a signal, what would need to happen to it so xt is a signal, I need to get something like this, say minus 3 xt. So can anybody answer that in the live chat? So I have an xt, I have xt as a signal, and I want to get minus 3 xt. So what operations do I need to do on the signal in order to get minus 3 xt? So please somebody post that answer in the live stream, on the live chat. So I have a signal xt and I want to get minus 3 xt out of it. What are the operations that I'm going to do on the signal? Please somebody post it on the live chat, so that actually I know that you are actually understanding, you're actually following me. Yeah, it says amplify with minus 3. But what is amplifying with minus 3? So amplifying with minus 3 has actually 2 steps, right? Yeah, multiply with minus 3. So multiply, first of all, so what we are doing, so these are the two steps. We have 2 steps right here. So the first, so 2 steps. So the step 1, so we have 2 steps, and in that we have step 1. What is the step 1? So the step 1 is taking care of the minus sign. So step 1 is simply taking care of the minus sign, right? So take care of the minus sign. So how do you take care of the minus sign? By flipping the signal about the horizontal axis, right? Right. So this is how we go about it. We take the signal, right, and first take care of the minus sign here. So we flip the signal about the horizontal axis, right? And then comes step 2. Then with that signal we go to step 2, multiply with 3, right? So we actually take care of it in 2 individual steps. We might as well do this in a single step, but this is the steps we actually follow in reality. So first of all, we take a minus sign and flip the signal. Because of the minus sign, we flip the signal, and then we take care of the scaling factor, right? So we do an amplitude flipping and then an amplitude scaling. And again, you would soon see that there is an order of precedence in the order of operations here, right? We need to follow a certain sequence of operations in order to get the correct result out of this time domain operations. So if you have a minus sign in the scaling operator, amplitude scaling operation, so take care of that first and then take care of the scaling factor. So if I have xt and I want to have minus 3 into xt, I first take care of the minus sign to flip the signal, and then I take care of the scaling factor here by just simply multiplying the signal with 3. That's quite understandable, right? So we're actually breaking the entire problem into small bite-sized pieces. So actually it's easier for us to understand and to make sure that we are not making any mistake down the line, right? So I think this is quite clear so far. Right? Right. Do let me know if you have any if you are facing any difficulty understanding me. Right. I think it's easy to understand, right? So we have just taken care of the amplitude scaling property, right? So we have taken care of the amplitude scaling property. Scaling operation, right? So let's now take care of amplitude shifting. So say again, let me draw here. Okay, wait, hold on. Right. So say this value is 1, this value is 0, this is time 0, so this is time t. So this is xt, right? So this is a very simple signal. I have a value of xt. So this is the signal represented with xt. So it's again a simple pulse which reaches a value of 1 here, right? So now question is how would I get from this? Question is how would I get something like xt plus, say for example 3, or say for example xt plus 1? How would I get that? What do I have to do in order to get xt plus 1, right? How am I going to get that? It's again pretty simple, right? So now I'm drawing xt plus 1. So what would happen? So when the value of the signal was 0, okay, that will basically be added up with 1. So whenever the value of the original signal was 0, those values will become 1. So whenever the value of the original signal was 1, those values will become 2. And simply all the amplitude values will basically be updated by adding a 1, right? So all the amplitude values will be increased by a value of 1, right? So very simple. So what would I do? What would I, how do I represent this amplitude shifted version of the signal? Simply by adding 1 to the original signal, right? Again, right. So very quickly you can understand that this value is now 2, right? This value is now 1, right? And again, this is t, this is 0. So nothing happened in terms of times, right? So at time t equal to 0, the signal jumped from 0 to 1, and now at time t equal to 0, the signal jumped from a value of 1 to 2, right? And it stayed at 2 like it was staying at 1, and then it went back to 1 like it went back to 0 here, right? So it's an amplitude shift operation, right? Very simple. So amplitude shifting basically means this, right? So if xt is a continuous time signal, then xt plus a, so adding any real number, right? Any real number. Uh, Simply adds a to the amplitude. Right. So again, pretty simple to understand. So with that said, let me ask you a question. Right. So now this is my question. I have xt as an original signal. How do I get minus 2xt plus 1 from this? How do I get that? So can anybody post the steps on the live chat? So again, right now here we have to first take care of the minus sign, then we have to take care of the 2, and then we have to take care of the plus 1, right? So what are the things? Yeah, right, amplify the signal with minus 2. So how do I amplify the signal with minus 2? First take care of the minus sign, then take care of 2. Yeah. Step 1, flip about the horizontal axis. Then step 2, multiply the signal with 2. And then step 3, add. Right, absolutely. So all of you are getting it, right? So it's not that difficult, right? So the steps are: flip about the horizontal axis, right? Then the next step is, okay, wait, hold on, I mean doing this drawing pad is slightly difficult, right? So first of all, try taking care of the minus sign. Okay, right. So flip the signal about the horizontal axis. Then step 2. Then step 2 is multiply the signal with 2. And then step 3, shift the signal up, right, by 1 unit, right? So I think this is easily understandable, right? So from xt, how do you get minus 2xt plus 1? First, flip the signal about the horizontal axis. So we have taken care of the minus sign. Then you multiply the signal with 2. So scale all the amplitudes by 2. And then you shift the signal up by 1 unit. Again, if you go back, you already have seen that shifting a signal, basically adding some positive value here. Okay, shift the signal up. So right now we have a shifted signal that was shifted upwards, right? So these are the three portions or 3 steps in the entire operation, right? So let's see that in action, right? Right. So we have this signal again, once again, we have this signal, and I have given you the program on Google Colab. You can execute the program without any issue. Okay, and you can see the code that I actually made for this. Okay, so this is xt, right? So first thing that I have to take care of is the minus sign. So what is the minus sign here? So that's an amplitude scale with a -1, right? So that's minus xt. So from xt I have gotten minus xt. Now once I have gotten minus xt, I can now make -2xt by simply scaling this up with a value of 2. Right? So now from xt I have -2xt. We already discussed how we got that. And then we have a amplitude shift of +1. Right? So again, let's go back a while. Right. So this is -2xt. So we flipped the signal and scaled it up by a value of 2, and now we have to shift the signal up by 1 unit. So this value, this times where the signal was 0, actually all those values will be shifted up to 1. So this value, which was 4, this amplitude which is 4 now, will be shifted to 3. This value, which is -2 now, will be shifted to -1, and so on and so forth. So amplitude shifting by 1 unit. So as you can see, so this is the resulting signal. So this is xt, and from that we have -2xt plus 1. So let me know if it is understandable, right? If you have any difficulty understanding, let me know. Right. So does anyone have any question? Anyone else have any question? Right. Right. So we have successfully taken care of all the amplitude operations, right? So amplitude operations consist of flipping the signal about the horizontal axis, scaling the signal about the horizontal axis, and shifting the signal about the horizontal axis, right? Right. Again, I have yet another question, last question for you. For example, hold on. So can anybody answer this question? So I have xt, I want to get this. So can anybody answer what are the steps in order to get this from this, right? I have xt, I want to get -2 multiplied with this entire xt plus 1. Right. Yeah. So again, quickly, so the easiest thing that you can do is first simplify the signal, simplify and expand, right? So yeah, so the simplification and expansion, so basically gives you, so from this I have, this is the original signal we are talking about, and this is simply -2 into xt minus 2, right? So which again has now 3 parts. So you first take care of the minus sign, so flip about the horizontal axis, right? Then we have this value 2, which is scale, which is multiply the amplitude with 2, right? And then we have a minus 2 here, right? Then we have a minus 2 here, right? So we have a minus 2 here, right? So we have a minus 2 here. So now this will be done by shifting the signal down by 2 units, right? Okay, so I would again emphasize on the order of the steps, right? On the order of the steps. If you shift by 2 and then shift by 2 units, okay, shift by minus 2 basically, okay, and then multiply, you would end up with a wrong result. So be careful about the operations. So the precedence here is this minus sign first, then this scaling factor, and then this shifting. So you have to follow the steps as I told you, right? So this is step 1, this is step 2, this is step 3, right? You have to follow them in the proper order, otherwise you would end up with the wrong result. So if you shift the signal first and then multiply, so if for example if you shift the signal with a value of minus 2, so if you shift the signal down by 2 units first and then multiply and flip, then it will automatically happen to be a wrong result, right? It will basically become minus 4 here automatically. Anyway, in any case, yes, so in any case, make sure to follow the precedence order here. So for this minus sign takes precedence first, okay, so flip the signal about the horizontal axis first if required, if the minus sign is there, otherwise don't worry about anything, and then take care of the amplitude scaling factor here, and then take care of the amplitude shifting factor here. So if there is a plus sign here in the amplitude shifting factor, so the amplitude is shifted upwards and the signal is shifted upwards, and if there is a minus sign here, the entire signal is shifted downwards, right? So with that said, I believe we have gotten to the end of this portion, right? We have talked entirely, we have finished discussing about amplitude shifts and amplitude scaling, right? So with that said, please let me know again if you have any question regarding anything. And again, giving me a wrong answer by mistake, it does not matter at all. Okay, attempting to answer a question is the most important thing. Okay, using your brain to solve something is the most important thing while you are a student, at least. Right. So let me know if you have any question regarding this. I will. Otherwise, I will move to the next topic. Right. So let's move on to the next topic here. So now we are talking about. So now we are talking about time shifting and scaling. Okay. So we talked about amplitude shifting and scaling. Now let's talk about time shifting and scaling. So we shall start here with time shifting. time shifting, right? Okay, thank you, Shamu. Okay, right. So let's talk about amplitude shifting. Time shifting, right? So now let's again draw something, and again, drawing is the most difficult task here, most challenging task here. But in any case, I shall try my best. Right. Let's draw a signal. I don't know, maybe this. Hold on. Right. So now I'm giving some values here, for example, 2 seconds. So this signal has a value of 1 while time is between 0 and 2 seconds. And before t equal to 0 and after t equal to 2, this signal has a value of 1, a value of 0, right? So here the signal's value is 0, here the signal's value is 0, and within these limits, the signal's value is 1. Now my question is, so I believe I taught you in an earlier class how to deal with these shifts, right? So what is xt minus 1? Now again, like the previous one, in the previous example, in amplitude shifting and scaling, we were multiplying and doing some addition subtraction with the amplitude. Now we are doing similar things with the time here. So now time here is being shifted, right? So now anything when added or subtracted with time is a time shift. Now we have this xt minus 1. Now you have to understand the signal pretty well in order to figure this thing out. So I shall start by not assuming anything and letting you figure it out yourself. First of all, what is the definition of this signal? Try to figure that out first. Okay, try to figure this mathematically, because one of the primary goal of this subject is to figuring things out mathematically, right? So here I can say the value of the signal is 0 when time is less than 0. The value of the signal is 1 when time is between 0 and 2, and the value of signal is again 0 when time is greater than 2, right? So that is how we have defined the signal, right? That is how we have defined the signal. So I don't think there is any issue with this, right? So when this is less than 0, this is less than equal to 2, this is greater than 2, right? So this is how we have defined the signal. Pretty simple, right? Now my goal is to find, so I am trying to find out what will xt minus 1 look like. What will xt minus 1 be? Right? So how do I figure that out? Pretty simply, try to understand that we have the same signal. So we have xt, so xt, right? So now we are trying to figure out what happens to xt minus 1. So yes, someone says, yeah, see, you're correct. See, try to understand what happens here. Yes, it will simply be shifted to the right by 1 unit along the x-axis, right? Along the time axis, not x-axis, but time axis, right? So here, try to understand how I actually do it mathematically, right? So actually figuring out the operation properly is very important here. So now try to understand. So here, instead of having t, what if I just have xt minus 1? So the definition of xt minus 1 actually follows from the definition of xt. And how do I define that? We simply define that the same way by simply replacing t with t minus 1, right? So for xt minus 1, I have 0, I have a value of 1, I have a value of 0. Now instead of having t here, I would have t minus 1 less than 0. I would have 0 less than equal to t minus 1 less than equal to 2, and then I would have 0 t minus 1 greater than 2. Right. So I think this is pretty easily understandable, right? So with that said, I can now write xt. So I can now pretty quickly define xt minus 1 as this. So I can now simplify this portion, and this portion, bring all the minus ones to the right hand side, and I would end up with 0 and 1 and a 0. So the signal has a value of 0 while t is less than 1. So this minus 1 is put to the right hand side of this, and now this signal has a value of 1 when 0 is less than equal to so again I have t. So this minus 1 is taken care of by adding the entire thing by putting plus 1 with this entire inequality. So this becomes 1, this becomes 3. Understandably, if t minus 1 is between 0 and 2, then t will be between 1 and 3. And the last one becomes simply by adding again, add plus 1 to add 1 to all the sides, one with all the sides, we have t greater than 3, right? So what happened? The signal simply got shifted. So look at this one. The signal had a 0 value before time was t equal to before time was 0, and after time is 2, right? Now here the signal has a 0 value before time was 1 and after time is 3, and between time 1 second and 3 seconds the signal has a value of 1. So simply if I go forward, and so of course the resulting signal would be like this, right? So this is 1 second, this is 3 seconds, and this magnitude value is 1, it does not change here, right? And this is your x t minus 1. So simply now if I ask you this question, how do you get x t minus, say for example, x t minus 2 from x t? How do you get this? So you have a signal represented with xt, and from that signal how do you get xt minus 2? Can anybody post it on the live chat? So can anybody tell me yeah, simply shift the signal to the right by 2 units, right? So now of course we are taking care of the minus sign first. Now here minus sign indicates a right shift, right? You have to remember all this information here. So this minus sign with this Okay, for time shifting operation, if you have a minus sign associated with t here, okay, so here, so this is a shifting value, right? This is the value with which we are shifting. So we have a minus sign which will indicate it's a right shift. And how much time am I shifting to the right? By 2 seconds. So it's a right shift. It's a right shift by 2 seconds, right? Right? So with that said, let me again go back to the program and reset everything here. Right. So this is again that same program, right? So now of course we have xt and this is again xt, right? So if I do something like this, now this is xt, this signal is xt, and this is xt minus 1, right? So the signal actually got shifted to the right by 1 seconds. Okay, so I have xt minus 1. So obviously if I do this, this signal now has got shifted to the right by 2 seconds. So whatever happened to this original signal at t equal to minus 1 is now happening to the shifted signal at t equal to 1. Whatever happened to the original signal at t equal to 0 is now happening to the signal at t equal to 2. Whatever happened to the signal at t equal to 1 in the original signal is now happening at t equal to 3, because I have shifted the signal to the right by 2 seconds. So right, so this is again quite easily understandable, right? Right. So with that said, let me ask you another question. So this is my question now. Of course, use your intuition and let me know. So I have xt and I want to get xt plus 2. What am I going to do? What are the operations that I have to follow in order to get xt plus 2? Now time is being shifted. Again, this is the time shift operation. Do tell me. Can anybody post it on the live chat? Yeah, simple, right? So again, the answer is pretty simple. You have to first take care of the plus sign now. You have to figure out what happens with the plus sign. What does it mean? It means it's a shift to the left. So simply left shift. By how much time? 2 seconds. So basically you can shift the signal to the left by 2 units. Absolutely. Left shift by 2 seconds, right? Right? So again, as you can see, so that's the original signal. Okay. And if I do something like this, right, we had a little bit of a technical issue with the network here. Right. So I believe this is working, right? Uh, right. So this is now. All right. So I think we are back. So we shall continue from here, right? I hope this works well for the rest of the class. Right. Please let me know in the live chat if the stream is okay again. If the stream is all right again, please let me know. I will start then. And you people can talk about PUBG later on. Right. So the internet has been pretty spotty since the lockdown. And I called up the ISP and they are saying they can only repair the internet after the lockdown is over. So yes, really there is nothing I can do about it. Right. So can we resume then? Right, from this point. Right. I hope this works for the rest of the class. Okay, right. We shall be here for 20 more minutes, so don't worry about it. I hope it works now. Right. So let me get back to it. So we were talking about this signal operation, right? So we have xt, and from this we want to. Okay, the sound is pretty weird now. Hold on. Yeah. Hello, sound test. Right. So we have xt, right? And from xt we wanted to get xt plus 2. Right. Right. So this plus meant we wanted to do a right shift. We wanted to do a left shift, and this was a left shift by 2 seconds, right? And we actually got to see that. Hold on, the Python server is somehow. All right. So I hope this is fine now. So I have another question for you. Right. So I have xt, right, and from that I want to get x of minus t, right? So right, someone says shift by one. No, 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 no. It's not shift by one, right? It's not shift by one. So same. Um, right. So I'm drawing a special kind of signal. So actually, so that you can visualize it properly. Say this is 3 seconds. This is 0 seconds. This is 1, 0. This is 1, and say this is 2, and say this is my xt, right? So I want to get x of minus t, right? So this is t, like right? You understand? You understand the objective, right? Yeah. So now, if you recall, if you had a minus sign outside, that would result into a flipping about the horizontal axis. Now we have a minus sign about the time, right? So what it means is that, so for example, this signal had a value of 0 and transited to a value of 1 at t equal to 0, right? xt. This happened to xt. So about the history of xt, what happened to xt? At t equal to, before t equal to 0, the signal was 0. At t equal to 0, the signal had a value of 0, but then it jumped to a value of 1. Then it gradually rose up to 2, okay, up until time was equal to 3, and then it dropped down to 0, and then it went on to being at 0, right? Now for for xt, for x of minus t, you can understand that the same thing will happen, right? So if you, for example, if you look carefully, okay, if I ask you this, what is the value of the signal when time is t equal to 2? What is the value of the signal? So somewhere between 1 and 2, right? The value of the signal here at time t equal to 2 is somewhere between 1 and 2, right? You can understand the same thing will happen here for this signal at time t equal to minus 2, right? So here, whatever point I had, whatever happened at t equal to 3, for this signal will happen at t equal to minus 3. Whatever happened to this signal at t equal to 0 will happen to this signal at t equal to 0 as well. Whatever happened to this signal at t equal to 1 will happen to this signal at t equal to minus 1, right? So essentially, you can understand that this simply results into something like this. Right? All right. So I think you can follow. So this is 0, this is minus 3, this value is 1, this value is 2, this is t, and this signal is now x of minus t. Right. Right. So just like a minus sign outside, okay, just like a minus sign outside basically means an amplitude flip, a minus sign inside associated with t means a time flip. So the x, now the signal has been flipped about the time axis, right? So it's called a time flip, right? It's a time flip, right? So I believe you can understand what happened here. So this t equal to 3 basically is mirrored to t equal to minus 3. As you can see, if you put minus 3 here, minus and minus will automatically cancel out and become x3, and so on and so forth. So let me go back to the program once more. Okay, and here you can see if I do a time scale, right? So this is, for example, this is xt and this is x of minus t, and you can see that it basically flipped about the vertical axis. So this is the vertical axis. The signal has now flipped about the vertical axis, right? So whatever happened after t equal to 0 has now happened in the other way around here. Similarly, whatever happened to the signal before t equal to 0 has now happened after t equal to 0. The signal has flipped about the vertical axis, right? Right. So a minus sign essentially means a flip. If the minus sign happens to be outside the signal, which basically means if the multiplied with the signal amplitude, with the amplitude, so that would be an amplitude flip, so flip about the horizontal axis. And if the minus sign is associated with time, that means it's a time flip, so it's a flip about the vertical axis. Right. Right. So now let me go back and ask you a question. So we have understood. So if there is any question before I move further, if there is any question, please let me know. Please let me know in the live chat if there is any question. If you have understood it properly, please let me know again. All right. So question is, right. So we have xt. My question is, how do you get x of minus t plus 1? So can anybody answer the question? Now, what are the operations that I need to do in order to get this, right? What are the operations that I need to do? So someone says flipped sideways, Obj says flipped sideways and then right shift. Someone says left shift. So someone says a same as xt. Okay. There is no vertical shift. Vertical flip or vertical shift will happen with amplitude flip and amplitude shift. So there is no vertical thing happening here. All the things that are going to happen here are horizontal shifts or horizontal flips. Yeah. Okay. So again, let me give you a very simple example of a signal. Very simple example of a signal, so that actually you can actually follow this properly, right? And we shall establish this mathematically. So there is no worry about that. Let me draw a very simple signal, so that actually you can understand it properly. Let me draw it first. So there is a lot of confusion, right? All of you are saying different things. Okay, only one of You are correct, apparently. So let me draw the signal. Right. So I think this is a very simple signal, right? So I have xt, right? So the value of the signal is 0 before t equal to 0. At t equal to 0, it jumps to 1, and then it gradually rises up to 1, rises up to 2. But at t equal to 1, it again goes back to 0 and stays at 0, right? Stays at 0, right? So question is, what are the operations that I need to do in order to follow this? But again, imagine you haven't studied signals and systems, but you have some idea of mathematics, right? So how would a mathematician try to figure this thing out? For example, if you are simply following this from the point of view of mathematics, right? So if you don't know anything about it, you have to figure out the critical points. So what are the critical underlying points here? So as you can see, one of the critical underlying points is this one, and one of the critical underlying points is this one, right? These are the most important points in the entire signal, right? They define the nature of the signal here. Okay. So now look carefully. This is happening. When is this happening, right? This is happening at t equal to 1. And when is this one happening? This one is happening at t equal to 0, right? These are the most important critical points here, right? About the signal. So with that information in hand, we can now proceed further and devise a way of analyzing this, right? Now for the original signal xt at t equal to 1, this happens to be the critical point. So let's name the critical points. Let's name this critical point A, and this to be a critical point B, right? Right? I think you can follow me, right? Right. So for the original signal xt, right, this critical point A happens to be happening at t equal to 0. And for the original signal xt, again, this critical point B happens to be happening at t equal to 1. Right. With that said, we just need to figure out what are the time instances at which these critical points happen for x minus t plus 1 for this new signal. What are the time instances at which these critical points happen? So again, recall critical point A. Okay, critical point A is happening at t equal to 0 for xt, right? Right. Therefore, for x of minus t plus 1, it will happen when minus t plus 1 is equal to 0. Try to understand. This critical point A that I'm talking about here happened to the original signal when t was equal to 0. But what is t? What is t, right? T is the internal argument of the signal, right? This is the time of the signal. So when time t, or the internal argument here, is 0, this critical point A happened, right? Now obviously my question is, for the shifted signal, for this signal x minus t plus 1, for this signal, when would this happen? So this same critical point would technically happen when this minus t plus 1, this entire internal argument of the original signal, is 0, right? So I think you can follow this point. So with this idea in our head, we can simply say that this critical point A will be happening for this signal, that is when, if you simplify this, at t equal to minus 1. So for the shifted signal, for this new signal, for this signal, the critical point A will be happening at t equal to minus 1. Similarly, if you can follow this, critical point B happens at t equal to 1 for xt. Again, for the original signal, when this internal argument this internal argument is 1, the critical point B happens, right? Takes place. So therefore, in the same vein, we can say, okay, this B will happen to x of minus t plus 1 when, again, when this minus t plus 1, this internal argument is equal to 1, right? When minus t plus 1 is equal to 1, right? So this critical point happened to the original signal when t was equal to 1. Now this, again, the same critical point will happen to this signal when this entire internal argument, which is the thing that is replacing t, right, since minus t plus 1, this is now equal to 1. When this is equal to 1, this point B will happen, right? So that is, this will happen when, if you simplify this, at t equal to 0, right? So please let me know what doubts you have, because I don't want to proceed from this point if you leaving you in doubt, right? So only if your doubts are clear, all of your doubts are clear, I can proceed further. You get the idea of the critical points, right? If you don't get the idea of the critical points, do let me know. So right. So I'm now trying to draw what we just figured out, right? So we have x of minus t. Okay, Mahesh is again asking, how did t equal to minus? Okay, the thing is, we are talking about the, again, let me go back to this. We are talking about the critical points. Okay, we are trying to figure out what happens if I do x of minus t plus 1, right? We are trying to figure out how to get this from xt, right? How to get x of t minus t plus 1 from xt. So in order to figure that out, we are figuring out the critical points, important points, the salient points that actually lets me define the signal. So this is a critical point. Yeah. So so for example here, these are the critical points, right? These critical points, look carefully what happens here. Okay, you people are absolutely correct. This is not minus 1, right? Okay. I got your point. So yes, if I solve this, this becomes t equal to 1. Thank you very much. So this essentially means you are actually following properly. Thank you very much. You people are actually following properly, right? Well, so we are trying to figure out when this happens to the new signal, right? So this happened to the old signal xt when t was equal to 0. Similarly, this critical point A will happen to this new signal when minus t plus 1 is equal to 0, right? Absolutely. Absolutely correct. You people are absolutely correct. So right. So the critical point A now refers to t equal to 1, and the critical point B now refers to t equal to 0. Yes, you people have corrected me, which basically means you are actually following properly. Thank you very much. Right. If there is any doubt, let me know. So right, so now for this signal we have established that critical point A would be happening at t equal to 1 and critical point B would be happening at t equal to 0, right? We have established that so far, right? So if we have established that so far, let me draw the signal then. Okay, right. So this is critical point A. What was the value of the signal at critical point A? The value of the signal was a jump from 0 to 1. So the critical point A is basically a value of 1 here, right? And the critical point A is happening at t equal to 1, right? At t equal to 1. So this is where the critical point A is happening, right? So this is my critical point A. This is my critical point A, right? This is the critical point A, right? Somewhere like that. So yes, this is time 1, this is time 1, and this is time, right? And this magnitude is of course 1, right? And where is critical point B? Where is critical point B? Critical point B is now happening at t equal to 0. Now where is this point? What is the magnitude? The magnitude is 2, right? So the magnitude is 2 and time t equal to 0. This is critical point B for the new signal, right? So for the new signal, this is critical point B, right? This is your critical point B, right? So I believe now you can proceed further and figure out the signal yourself, right? So you did figure this out yourself. Right. So this is how we got from xt to x of minus t plus 1. But can anybody tell me what are the operations that actually happened inherently here? So from this we got this, right? So do tell me, can I say something like this? So we are trying to figure out this, right? X of minus t plus 1, right? So what did I get? So the first thing, so we can say, we can devise this in 2 steps, right? Step 1, flip the signal about the vertical axis, right? And then step 2, shift the signal right by 1 second. So do tell me if you can follow this, right? So from xt, so we had xt, from xt we wanted to get this, and these are the operations we say we followed. We flipped the signal about the vertical axis and then we shifted the signal right by 1 second. See if you can follow. Let me know please. Let me know please if you can follow. Please let me know in the live chat if you can follow this. Then I'll proceed further. Yes, absolutely, Shambhama, I shall be answering your question. But my question is for right now. My question um, is it understood whatever I have done so far? I'm going to tell you why this was right shift now. Yes, this is my question. Do you understand this mathematically? All of you, right? Shambhama, I shall be answering your question shortly. Don't worry. Yeah. So if you can follow this far, let's again recall what we just did. We wanted to get from xt to x of minus t plus 1, right? But so far previously, what did we establish? We established so far previously we established, if you have a plus sign here, that indicates it's a left shift, and if you have a minus sign here, this indicates it's a right shift in time, right? Now again, look very carefully. The signal is shifted right if we add some negative quantity with time, and the signal is shifted left if we add some positive quantity with time, right? Again, I'm repeating myself. If we add some negative quantity with time, the signal is shifted to the right side, and if we add some positive quantity to the time, the signal is shifted to the left. With that said, my question is, did we add a positive quantity or a negative quantity with time here? Did we add a positive quantity with time here, or did we add a negative quantity with time here? This is my question here right now. What did we really add with time? Did we add a positive quantity, or did we add a negative quantity with time? Please answer the question in the live chat. Did we add a positive quantity or a negative quantity? Yes, OV is absolutely correct. We added a negative quantity. This is not a negative, not a positive quantity. We actually added a negative quantity with time, because the next line is something like this. If you try to follow, we added plus 1 with minus t, which indicates we added minus 1 with t, right? Right? So yes, you are absolutely correct. So if you take the minus sign outside, now you can figure out what we added with t, right? So now as engineers, we can follow this operation this way. So this is my step 1. My step 1 is taking care of this minus sign. So this is step 1. Flip the signal vertically about the vertical axis. And since we have added a negative quantity with time, okay, we shift the signal to the right by 1 unit. So this entire thing indicates our step 2. Shift the signal right by 1 second. Right. Yes. So it's basically minus of t minus 1. So please let me know if all of you can follow. Okay. So let me switch to the program again. Right. So similarly, if you do, so we already have x of minus t, right? So we have x of minus t. So we have flipped the signal. And now if you want to do something like this, so this is xt, and this is now x of minus t minus 1. Okay. So x of minus t, so we're talking about x of minus t plus 1, right? X of minus t plus 1. Look carefully what happened here. so this is x of minus t, and if we do x of minus t plus 1, the signal will be shifted to the right, because doing x of minus t plus 1 is nothing but adding a negative quantity with time here. No. The signals are flipped to the horizon with respect to the horizontal axis only when there is a flipping in the amplitude, right? Right. Yeah, with respect to time, flipping with respect to time, absolutely, because we have a minus sign with time, right? Not with the amplitude, right? So I will quickly move over. Right. So we have talked about this amplitude shift and flipping here. So the next point is see, so let's talk about time scaling. Right. So very quickly, let me draw a very simple signal here. So that it's easy to follow again. Let me draw a very simple signal. Right. So this is a very simple example of a signal where the signal's value is 1 between time 0 and 1, and beyond those values, beyond those time limits, the signal is 0. Right. So with that said, my question now is how would you get x of t by 2? So question is, how would you get x of t by 2? Again, let's do it mathematically. Try to understand that this signal can be represented like this. This signal has a value of 0 when this signal has a value of 0, it's a value of 1, say this signal has a value of 1 between these two time limits. No. You cannot do a up shift or down shift with time, right? Because with time it can only shift or scale horizontally, right? It cannot happen vertically, right? In order to do a vertical shift or vertical scaling, you need to have a time scaling amplitude scaling factor, right? Right. So let me just do this, you will see. Right. So when time is between 0 and 1, the value of the signal is 1. Yes. OB is correct here. So let me explain. Okay. Now same thing. How would I explain this? So if this is xt, how do I mathematically represent x of t by 2? The same thing. So talking mathematically, you just have to replace in the definition, you just have to replace this. Sorry. If this is something you can follow, let me know. So from this signal, I want to get this signal. How do I do that? Let's do it mathematically. And how do I deal with it mathematically? By just simply putting t by 2 instead of t. Yes. So, right? So what is this? By definition, this is 1. So just multiply. Yes, you people are correct. So this is multiply everything with 2. So I have this, right? So if this is something you can follow, then of course uh, you can understand that we have been talking about this. Anyway, so right, so this is xt, right? And I want to have x of t by 2. So let's draw once again. I want to have x of t by 2, right? So simply this will happen. The signal will now get elongated in time, right? So now this happens at t equal to 0, this happens at t equal to 2, right? So do let me know if you can actually follow this. So I can say from x, so x t by 2, this by 2 indicates time expansion by a factor of 2. Right? And similarly, can somebody tell me what this will be, right? X of 2t. If you do it mathematically, you will quickly see that this will result into a time contraction, right? So the result would be just the opposite. Yeah. So this was the time expansion. The previous one was the time expansion, and similarly, x2 into t will be, this means a time expansion sorry a time contraction or compression, whatever you want to call it. By a factor of, yeah, the width of the signal gets reduced to half, right? So again, let's switch back to this. We will end shortly, so don't worry. Okay, so now again, let's get the original signal back. Right, so this is the original signal, right? So this is xt, right? So what if I do x of t by 2, so x of half t, right? So this is xt, this is x of t by 2. So x of half t. So the signal just got the time actually got enlarged by a factor of 2, right? So time expansion with a factor of 2, right? So whatever happened here at t equal to 2 is now happening at t equal to 4. Whatever happened at t equal to 1 is now happening at t equal to 2. Whatever happened at t equal to minus 1 is now happening at t equal to minus 2. But whatever happened at t equal to 0 stayed at t equal to 0, happened at t equal to 0. Right? Just the same way, if you do a time scaling with a factor of 2, so we have x of 2t, you see this signal got time contracted, okay, time compressed by a factor of 2. So whatever happened here to the original signal at t equal to 2 is now happening at t equal to 1. Whatever happened to the original signal at t equal to 1 is now happening at t equal to half. Whatever happened to the original signal at t equal to 0 is now again happening at t equal to 0. And whatever happened to the original signal at t equal to minus 1 is now happening at t equal to minus half. Right? So with that said, I will just end with two questions to you and you will answer me anyway. So let's go back to this. If there is any question so far, let me know. So now I have a big question for you. So you have to follow quite a few steps, but do tell me what are the steps you need to follow. So from xt, I want to proceed in a step-by-step fashion and figure this one out. So we have xt given, for example, and I want to figure out what is the nature of minus 2x into minus t by 2 plus 1, minus 1 plus 1. And again, you would have to follow a certain order to achieve this. To tell me. Someone in the chat, what is the first step? What is the first step? So, can anybody tell me what is the first step? Okay, right. So let's simplify this first. Okay, by simplifying this first, we have minus 2 and then x, and then take a half common out of this, and we have a t plus 2 and then plus 1, right? Right? Yeah, that's the first step. Simplification is literally the first step. So we are not talking about minus 2 x minus half t plus 2 and then plus 1. So let's do it step by step. So these are the precedents here. So the time operations do take first higher precedence than the amplitude operations. So one by one. So step number 1 would be taking care of the minus sign. So this is step number 1. Flip about the vertical axis. That's step number 1, right? right? Then what is step number 2? Step number 2 is taking care of the half here. That's step number 2. So time expansion, that's the time expansion by a there is no multiplication with 3. Time expansion by a factor of 2, right? Right. Then we have this plus 2. So it's a plus 2. So what kind of shift is it? Right. So it's a left shift, right? So left shift by 2 seconds, right? Then take care of this minus sign. That's your step number 4. That's your step number 4. Flip the signal. Vertically, about the horizontal axis. Right? Then take care of these 2 here. Multiply the amplitude by a factor of 2. And then we have this 1 here, which means that's our step 6. Shift the signal up by 1 unit, right? So those are the steps. That is how you get from xt to this, right? So please let me know if you can follow all the steps. Yes, absolutely correct. Absolutely correct. So we have to gradually start working from the time section. So we have to first take care of the time flipping, if there is any. Then we have to take care of the time expansion or time contraction. Then we have to take care of the time shifts. Then we have to take care of the amplitude flipping, if there is any. And then we have to take care of the amplitude scaling. And then we have to take care of the amplitude shifting. So first time flipping, then time scaling, then time shifting, then amplitude flipping, then amplitude scaling, and then amplitude shifting. That is how you have to gradually follow. And then again, before anything, you have to first simplify the signal into this form, right? So please let me know if you can follow, because this kind of time operations on signals will be quite an usual scenario in our subject here. So understanding this is pretty important. So as a homework, So this would be your homework. So I'm drawing a very simple signal here. So this is your xt. So my question is, if this is xt, this is how xt looks like. Okay. My question would be to plot minus 3 x of minus half plus 2 minus 2. Right. So this would be your homework. So do that and send me send the answer on my email ID and email me the answer, right? So do the plot and email me the answer. That will be your one of the assignments. Okay, and this would be worth 5 marks for your semester. So please try figuring this out. So if this is xt, you have to figure out minus 3x of half. Oh, I just skipped t, right? Right, so do that. So write down all the steps. Yeah. Of course, there is a T which I somehow managed to skip. Anyway, so yeah, do that and send me the answer. So you have to write down all the 6 possible steps that might happen here and draw the resulting signal. So if you have any questions so far, again, this video will be available. We had a technical glitch and thanks for staying with me. And this video will be available after the stream. And I shall send you the handout to your group email. So yes, if you have any question, I will be staying here for 5 more minutes. If you have any question, please let me know. Yeah, you can submit the answer by sending it, by emailing it to me. Okay. So of course you know my email ID, right? At technoindiaeducation.com. This at technoindiaeducation.com. Well, thank you very much for staying. If you have any question, you can ask me now, or you can send the questions later. Thank you very much. You people are learning Spanish, right? Yeah, those who have responded here on the live chat, they will get the attendance automatically. And for anyone else who attended the stream but did not write anything on the live chat, please say attendance or say something at least so that I get to see your name here. I shall let you know about the next class. And please let your friends know because I would expect slightly more people to join. Right. Anyway, thank you very much. So if you have no more questions, we're going to end the stream right now. And well, thanks for joining. And I shall let you know about the next class. Well, thank you very much.